In this video, I'm going to go through the answers to all of those exam questions. If you haven't actually done the exam questions yourself, then please press pause, do the exam questions first, and then come back here for the answers. You'll learn nothing if you're just sitting watching my answers. The first one, the answer is going to be gold, okay? They're asking you for the one that's uncombined. Gold is uncombined because gold is unreactive. The next one we've seen tons of times before. I've got carbon, which is more reactive than iron. Because it's more reactive than iron, it can take iron's place, and you get carbon dioxide and you get iron left by itself. If you wrote carbon oxide, you can still give yourself the mark. So you get 1 mark for carbon oxide or dioxide and 1 mark for having iron by itself. What happens to the iron oxides during this reaction? Well, if you look at the left, iron oxide, you've got oxygen with the iron. And if you look at the right, you've got iron by itself. So iron oxide is losing oxygen. That oxygen is being removed from the iron, going from the left to the right. And the removal of oxygen is called reduction. I know we have another definition for reduction. From oil rig, we say reduction is the gain of electrons. But in this case, we're using the reduction is removal of oxygen definition, and we're identifying that iron oxide is being reduced. The next question, okay, the first part is kind of a physics related, okay? They want to see, or they want to ask how you can ensure that current is definitely flowing. If I wanted to make sure the current was definitely flowing through a circuit, I could just put in a light bulb. Once the bulb shines, I know that electricity is definitely flowing. The other thing you could put in, and again, this is more physics related, would be an ammeter to just show you that the current was actually flowing around your circuit. What is meant by the term electrolyte? Okay, so electrolyte is a substance that conducts electricity, and you'll get a mark for mentioning conducts electricity, but it only conducts electricity when it is molten or aqueous. And your second mark comes from mentioning molten or aqueous. Instead of molten, if you wrote liquid, and instead of aqueous, if you're in solution, that's fine, but you need both of these things to pick up the second mark. Which of J, K, and L are electrolytes? If we look at J, K, and L, we see that J and L conduct electricity when they're in solution. That makes them electrolytes. K does not conduct electricity when it's in solution, so K is not an electrolyte. So I'm doing B, J, and L only. The next question, okay? They say you're electrolyzing copper sulfate, okay? Copper is a metal. Copper is going to be positively charged, and it's going to go to the negative cathode. And what you see happening is that the mass of the cathode increases. It's increasing because all of that copper from the copper sulfate is moving to the cathode, and it's forming a metal around the cathode. To calculate the mass, you simply take the mass of the cathode at the end of the experiment and take away the mass of the cathode at the beginning of the experiment. And this question is for 2 marks, and you get 1 mark for just showing the calculation and the second mark for calculating the correct answer. If you just had 0.29, then you get the 2 marks even without showing your working. The next one, identify the products of the anode and the cathode. So I'm going to remind myself which is which. Panic, positive anode, negative is cathode. When molten, because it's molten, there is no water present. So I have got no H plus or OH minus. So hydrogen is not going to be an answer here. All I do have is potassium iodide. I can split potassium iodide up into K plus and I minus ions. They're the only ions I have. The K plus ions will be attracted to the negative cathode, and the I minus ions will go to the positive anode. Now this is really important. If you left that as your final answer, you're not going to get any marks. The product at the cathode is not a K plus ion. That K plus ion is then turned into normal potassium. So to get your mark, you have to actually write potassium. And to get your mark above, you have to write iodine. You need to give the name of the elements as they appear on the periodic table. You don't write down the formula of the ions. You can use the ions to work out your products, but ultimately your final answer has to be from the periodic table, so that has to be iodine and not iodide. The next one, I know we're doing electrolysis, but moles questions come up everywhere, and this is a moles question, and I'm going to be drawing my table. The way I know it's a moles question is you're asked to calculate the mass of something, and you're given a balanced chemical equation. And that always tells me that I'm going to use my moles table. They ask for the mass of sodium, so I'm going to put sodium in my table. That can be formed from sodium fluoride. Okay, NaF is sodium fluoride. So they're the two things I'm going to put in my table. And then I'm going to have mass, formula mass, moles, and ratio. The mass of sodium, okay, that's what I'm trying to find. That can be formed from 168 grams of sodium fluoride. Formula mass, usually I'd calculate this myself using the periodic table, but they've already given me all of this information. The formula mass of just sodium by itself is 23. The formula mass of sodium fluoride is 42. And remember, when you're doing formula mass, you're never using the big numbers from the balanced equation. We use the big numbers for ratio, we don't use them for formula mass. When I'm calculating moles, okay, I have my formula triangle, which has mass at the top, moles, and formula mass. So when I want to find moles, it's going to be mass divided by formula mass. It's going to be 168 divided by 42, which equals 4. I can't do the same for sodium because I don't have a mass, but I do have ratio. To fill in the ratio, I use the big numbers from the equation. The big number in front of NaF is 2, so I write down a 2. The big number in front of sodium is also 2, so I write down a 2. The ratio of 2 is to 2 can be simplified is to 1 is to 1. These two numbers are both the same, which means these two numbers for moles must both be the same. If this is 4, then this must be 4. And to calculate mass, you see mass is moles multiplied by formula mass. So it's going to be 4 multiplied by 23. And that gives me 92. If you had an answer of 92, give yourself 2 marks. If you didn't get 92, but you did have 4, during your calculation, you can give yourself 1 mark for 4. The second mark goes for 92. The next one, you're reacting a metal and an acid. They want to know what gas is given off. Anytime you react a metal and an acid, you always get a salt formed and you always get hydrogen gas. So your answer here is going to be hydrogen. Just to show you why, if you're finding that hard to remember, okay? I have zinc and I've got hydrochloric acid. The only elements I have on the left-hand side are zinc, hydrogen, and chlorine. I don't have any oxygen on the left-hand side, so I can't have oxygen on the right-hand side. That means it definitely can't be oxygen. It also definitely can't be carbon dioxide. Again, I've got no oxygen on the left. I've also got no carbon on the left. Okay, so you're not going to form carbon dioxide on the right. Chlorine and hydrogen you do have on the left-hand side. But what happens when you form the salts, the metal, zinc, is going to pair up with the chlorine and you're going to get zinc chloride, and then you're just left with hydrogen gas. So hydrogen is going to be your answer. Give the name of the method used to extract aluminium. You need to know that aluminium is more reactive than carbon. Use your reactivity series. Because it's more reactive, you're going to use electrolysis. And it tells you down here, why is aluminium extracted by a different method instead of heating it with carbon? So they're telling you you're not using carbon, and you're going to say aluminium is more reactive than carbon. Because it's more reactive than carbon, carbon cannot extract aluminium. You could also say carbon is less reactive than aluminium. So aluminium is more reactive than carbon, or carbon is less reactive than aluminium. Oops, sorry. The next one, which material is most suitable to make the electrodes? Okay. For the electrodes, you need something that can conduct electricity. You also don't want it to be reactive, and you want it to have a high melting point. Graphite is going to be your answer. Okay, zinc is a metal, so is iron, so they can both conduct electricity, but they will react. Graphite is really unreactive. It's what you use in your pencils, okay, very unreactive. Sulfur is not a metal. It doesn't conduct electricity, so sulfur would be utterly useless as an electrode. The next one, we've got another moles, okay? Again, you're asked to calculate mass. You're given an equation. I'm going to use my moles table. It says 15 grams of pure copper carbonate, okay? There's copper carbonate. Okay, it's copper with a carbon and an oxygen. So I'm going to put copper carbonate in my formula. And it wants the mass of the solid produced. So you're producing two things, a solid and a gas, and they want the mass of the solid. So I'm going to put CuO in my table. I'm not going to put carbon dioxide because it's a gas. And then I'm going to do mass, formula mass, moles, ratio. The mass of copper carbonate, okay, they're telling you it's 15 grams. You're asked for copper oxide. Formula mass, you need to find the formula mass of copper carbonate, okay? So when I'm doing formula mass, I use the small number. So copper, they tell me here, is 63.5. Carbon, they tell me, is 12. And then oxygen is 16. And I've got 3 oxygen. So I do use my small number. So 16 times 3 plus 12 plus 63.5 equals 123.5. And then for CuO, I'm going to do 63.5 plus 16. And I get 79.5. Now that I've got mass and I've got formula mass, I can find my moles of copper carbonate. So it's going to be 15 divided by 123.5. And that gives me 0. And I'm going to write this to 4 decimal places for now. And then I'm going to round it at the end. So I'm going to get 0.1215. Okay. Then I'm going to use my ratio. The ratio is just 1:1. There's no big numbers in your equation, which means the moles of copper oxide is also going to be 0.1215. And then I multiply that 0.1215 by 79.5. And I get 9.65, which I'm going to round up to 9.66 grams. Okay, that's a lot of work for 2 marks. Normally that would be worth 30. If I scroll down to figure 3, okay, chlorine is produced at one of these products. What is the name of the electrode where chlorine is produced? So I know that chlorine is negatively charged. It's going to be attracted to the positive anode. The name of the colorless gas formed at the negative electrode. The negative electrode is the cathode, okay? You are electrolyzing sodium chloride solution. So you have got Na plus and Cl minus, but you've also got H plus and OH minus. And at the negative electrode, all of your positive ions are going to go. So you're going to have Na plus and you're going to have H plus. It tells you you're forming a gas. So you know hydrogen is going to be the one that forms. Hydrogen's less reactive, hydrogen will form. They want you to show, ignore electrolysis for a second. They want you to show that something's an alkali. If you're showing something's an alkali, you're going to use some sort of indicator. So I'm going to use universal indicator. So name an indicator and then say what color it will turn in an alkali. Universal indicator will turn purple. Litmus paper will turn blue. So give me an indicator. Tell me what color it's going to change. Why does solids, we've had this so many times. Why does the solution conducts electricity, but solid doesn't? And you're going to write in the solid, the ions cannot move. And in the solution, the ions can move and can carry current. You have to mention ions. Ions cannot move, ions can move for your 3 marks. And the very last one, what we did on Friday, the half equation for chlorine gas. Okay, so they want the formation of chlorine gas. They're telling you you're forming Cl2, but I'm going to do it the way I always do. Chlorine, I know, is an ion. It starts out as an ion, it's Cl minus, and it's becoming something neutral. It's becoming an atom. Okay, to do that, it's gained an electron, so it's going to lose that electron. But I know it's diatomic, so I'm going to put a little 2, a big 2, and another 2. And like all of my half equations, I've only got one element included. It's just chlorine. I've got electrons. I've got something charged, an ion on the left. I've got something neutral on the right. And these signs are matching. Okay, it's balanced. I've got 2, 2, and 2. I'm using a small 2 for the Cl2 to show that those 2 atoms are bonded together. And I'm using a big 2 over here because the ions are not bonded together. You've just got 2 of them. When you're finished doing this and marking your work, please take a photo of it and send it to me.